what's on the test. Before we start, because this is the last thing on the test, is alternative series. So let's see. Okay, so first thing, in 9.1, we pretty much learn about what is a sequence, right? There is multiple way of sequence. There was arithmetic sequence, there was geometric sequence, and there is other type of sequence, for example, n squared minus 1. So those are multiple different type of sequence. Also, we're supposed to learn about recursive, but I didn't teach recursive because it's never on the AP exam. And it's also something that you're going to use for other situation rather than this situation. So I'm trying to just focus on whatever is going to be on the test. Recursive is based on your prior term. So those are different kind of sequence. But mostly 9.1, the most important things like how do you do monotonic, right? How do you test for monotonic? How do you test for take a derivative, right?
Or you can do the comparison.
And the second thing is compared to the a to the n plus 1. Either less or greater, right? Compared to a to the n, which is you can compare that with the algebraic perspective. And you can figure out, are they always monotonic? Maybe after several terms. Sometimes maybe after the second term is monotonic. You can say that. But
so can it be n minus 1 also? Or?
Just usually you compare a to the n plus 1 and a to the n. So that's 9.1. 9.2, we learn about two type of series. Which two type?
Reciprocal?
Telescopic? Telescopes series? What else? 9.2, I think is geometric. You're not wrong. No, geometric. Geometric is a summation of n equal to 1, infinity of a1 to the r to the n minus 1. That's equal to a over 1 minus r. You must memorize this equation. Now, I can use this to convert fractions, convert decimal to, so you can convert repeating decimals to fractions. Okay, you can use to find out, but you have to make sure match this part. The hardest part is match this part. Remember that one with, I think 27 over e to the 3, or e times e minus 1, something like that. I forgot what the question was, but yeah. But definitely knowing between pi and e which number is bigger, because sometimes when r is greater than 1 is diverge, greater or equal to 1, absolute value r is between 1 and 0, then it's converge. Only converge, you can get this. Diverge, you cannot get a sum, because diverge, if it's sum, it's going to be infinite. Is that okay? So that's telescope series and sequence. You're supposed to know that. But 9.3, we know two different tests, the integral test. Now, in order to have integral tests, you must have show me that you can test for CPD. That means continuous, positive, and what's D? Decreasing, yeah. So COVID positive, die, whatever.
Wait, so for the test, do we have to prove all three of those things for you?
Yeah, you have to show me that they are continuous because there's no asymptote, right? And positive because You can say this is always positive. You can like that. It pretty much doesn't need too much proof because 1 over n plus 2, if n is greater than 1, then it's always positive.
Yeah.
But decreasing, you have to prove by two different ways, right? Proving from either use monotonic, use the a to the n plus 1 to compare to the a to the n. Now, in this one, integral test, you had to do improper integral. Oh, by the way, telescope series is usually two fractions. Or can be make it two fraction by decompositions. Do you remember? Like you have to decompose two. If bottom is factorable, you can decompose those two fractions, and then you can see the first few terms working out, and you can see what's the sums going to be. I don't really care about that extra parts of it, but that's to show you how do they get a telescope series. 9.3 integral test and P series. P series is my favorite series because they are too easy. P series is geometric. Minimum. Anybody like going to Calc 2 should understand P series geometric because they are so easy. Like, even cavemen can do it. You never seen a Geico commercial? No, man. You got AdBlock. Okay, anyway. So P series is 1 over n to the P summation n equal to 1 to infinity. If P is greater than 1, it's converge or diverge? Converge, thank you. Now P is equal to 1 or less than 1 is diverge. Now you can definitely use integral test to find out the sum.
It can't be less than 0, right?
Yeah, because less than 0 is going to be flipped over to become n to the P on the numerator. So P has to be less than 1. So greater than 0.
Then wouldn't it become geometric?
No, this is not geometric. This is a P series.
No, I'm saying if P was negative.
Squared, that's, keep going on. What if it and like sing that card down?
9.4. We got direct comparison test. It just compare. So, for example, how do I know 1 over n plus 2 is diverge? What do we compare to? 1 over n. You can do integral test, by the way. It's not wrong. You can do integral test, but you can also compare with 1 over n, because 1 over n plus 2 is smaller than 1 over n. So if 1 over n is diverge, wait, that doesn't mean anything, right? That's not a good comparison, right? So what can I do instead?
Whatever answer remains to pairs.
Huh? Limit comparison test. That's Charlie's favorite test. He says that test was way easier than any other test. Because if you compare to 1 over n, so I'm going to just do 1 because a lot of you guys, I was going around look at your homework. A lot of you guys doesn't know what limit comparison test is. So let's just say if you have summation of a to the n, and this one is 1 over n plus 2, and n equal to 1 to infinite. We compare to 1 over n, and we say 1 over n is diverge. So compare to 1 over n. And this is a diverge, right? This is diverge due to harmonic series. Oh, by the way, we do not learn about harmonic series now. So because that same thing as P series can prove harmonic series, or integral test can prove that as well. And we say, oh yeah, this is diverge, but this is less than diverge. If something is less than diverge, is that converge or diverge? It could be either one. Yeah. If I am less than Elon Musk, I have less money than Elon Musk, right? The thing is, I could be Bill Gates, which is second rich person. I can Jeff Bezos. That wasn't intended to be Jeff Bezos, sorry. Or I could be me on teacher salary. So I could converge or diverge. So if I'm less than diverge, doesn't mean that I am I'm converge or diverge. Also, I did forget about two different type of series. In the telescope, we also learn about n-term divergence test.
Yes.
What is n-term divergence test?
Does not equal zero.
Infinity if it does.
N-term divergence test. Now, this one only tests if it's diverge. So limit as n approach infinity of a to the n is not equal to 0, then it's diverge, right?
Yes.
So this is a very good test to test. Immediately you can tell if the function is diverge or not. Very useful. Very, very, very useful. So then this one, you're gonna compare. How do you do limit comparison test? You compare a to the n to the b to the n. Summation of that. If it's equal to L, then is diverge or converge, but they have to be the same as the one you compare with. So what does that mean? That means n equal to 1 to infinity. So then I'm going to say limit. Actually, this is limit, sorry. Limits n approaching infinity. So I'm just compare this 1 over n plus 2. 1 over n plus 2 over 1 over n approaching infinity, then that's going to be eventually limit n approaching infinity. That's going to be n over n plus 2. And that eventually is going to be what? Divided by n is 1, right? So if it's equal to 1, now if this is diverge, the one that you compare with is diverge, then this one must be diverge as well. So summation of n equal to 1 to infinity of n plus 2, that's equal to diverge.
Yes.
Okay, so that's all the things that we have learned so far, but this is actually super useful. Charlie did the other day, I was walking around, he did say, I think the easiest thing to do is limit comparison test because you don't have to do too many things. There's not too many parts in play. You just have to compare the series you know, and if you come out a number, it's going to be the same result as that series you compare with. Yes.
Could this work also like for all of the ones, like even the ones that, let's just say you could use direct comparison test, even if you use limit comparison test, would it still work?
It will probably work because I feel like limit comparison test is more powerful.
Okay,
Because, for example,
'cause you can't.
for example, this one doesn't work, but other question you could do direct comparison test, it would work.
It would work if you do limit.
But limit comparison test would usually always work. I'm not gonna say always,
Because like
but
direct-
it's a more likely it's more powerful situations.
Okay.
Okay, so now we finally got down to the last part. The last part is gonna be the alternative series test. So 9.5 is alternating series test. Now this is very popular in AP exam. Very popular. Now, what do you think about what is the series, right? What would be the series here? So you're gonna say, well, let's go to look at the situation here. So what does that mean? So this means a series where it's alternate term.
Alternative like signs.
Okay, sequential term. is the alternate signs. So for example, a good question would be like this. N equal to 1 to infinity of -1 to the m minus 1 over n. So let's write out the first few terms. I'm going to show you, and you guys going to understand what does that mean. This is equal to, if I write out first term, the first term is going to be what?
Zero.
1 minus 1 is what? 0. Anything to the 0 power is what? 1. And 1 over 1, so it'll be 1. So what will be a second term? -1. No, -1 what? -1 half. Plus 1/3. Minus 1/4. Plus 1/5. Dot, 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 dot. Does this look like something that we know before, but it's not exactly the same? It look like what? It look like harmonic series. But it's not harmonic series. This is called alternating harmonic series. Now we know harmonic series is what? Diverge or converge? Is equal to diverge. Right? Equal to diverge. Harmonic series, which is summation of n equal to 1, infinity 1 over n. That series is always diverge, but harmonic series is actually converge. Think about the first day you have one pizza. The second day you're gonna eat 1/2 of that pizza. And third day you're gonna make 1/3 of pizza. And the fourth day you're gonna subtract 1/4 of pizza. It's not always adding anymore, right? It's not always adding. You are adding some and you subtract some. You're adding some, you subtract some. You're adding some, you subtract some. Long as you have this is gonna be alternative harmonic series. That's always converge. But due to what? Due to alternative series tests. What's alternative series test? Well, the alternative series test is this. So also known as shorthand, alternating series test. It's going to be an is greater than 0. But it's going to look like this. It's going to be summation of n equal to 1, infinity of -1 to the n to the an, and summation of n equal to 1 to the infinity of -1 to the n plus 1 to the an. So either it's -1 to the n or -1 to the n plus 1. Why there's a difference? Well, depends on your first term is negative or positive. Does that make sense? One of them, the first term is positive. One of them, first term is negative. Doesn't matter which way is it. If it fulfill two conditions, then they will be converged. So which two conditions? First condition is limits. Well, first condition, they have to be alternating. It has to be plus minus, which is the first two, right? So I'm just going to write out for you. So this means it's actually same as this. Is that okay? It has to switch positive, negative. It has to switch. It cannot be two positive, two negative. There's another way to do that one. But two positive, two negative, two positive, two negative, that doesn't really work. But it has to be switch. So it has to be have a -1 to the n or -1 to the n plus 1 in front of the series. Now, second thing is limits as n approach infinity, an is equal to 0. What does that look like? Look kind of like n-term divergent test, right? But this time, n-divergent test is not equal to 0, therefore diverge. But this time, this n equal to 0, that's a good sign. That means they are gonna approach 0 when I do limit and approach infinity. Now, I'm not doing it to the -1 to the n to the an. I'm only doing it for exactly series that without the changing term. So I kind of get rid of that changing term. And I say, hey, let's approach infinite. If it goes 0, that's a good sign. The third thing says a to the n plus 1 is less than a to the n for all n. What does that mean? If you can prove, is it proof decreasing? Right? If it prove decreasing, then you are good. Then with all this, that go to converge. The series converge. Sorry, that was really ugly. It's not better, but whatever.
The summation you wrote on the top right, that's if a to the n is less than 0. The one that you have n plus 1 in the exponent, that's if it's negative.
What?
The two you have on top right now, though.
Yeah, this too.
Yeah, the one on the right,
Uh-huh.
is that where a to the n is less than 0?
No,
So
this
what's the
this
difference?
a to the n is all gonna be positive.
What's the difference between those two?
This two?
Yeah.
Is your first term. Think about your first term. For this one, n equal to 1 is gonna be negative. Your first term is negative. This one, your first term is what?
Positive.
It's a positive. So
It's the same.
same. It just what's the first term?
It's like shifting sine cosine. Just
Yeah, it's just like that. Okay, so now let's prove the alternative series test. Let's prove alternative series test. Let's say, hey, so let's say summation of n equal to 1, infinite of -1 to the n plus 1 over 1 to the n. Well, this part is tells me what?
first term is going to be positive.
That means, yeah, it's alternating. You're right. And
Isn't that the exact same equation you just showed us? That is.
It is.
The same.
it is, but I have to prove to you that this is converged. Okay, so we have alternating check, right? Its limits n approaching infinity of 1 over n is equal to 0.
Yeah.
Yes, checked.
Wait, why?
Wait.
Because 1 over infinity is 0.
Oh.
1 over infinity is 0.
So you don't include
No.
the first part?
Well, we don't need to.
No,
That's
you
gonna.
Because we only got to the a to the n. We don't worry about are they alternating or not. We already take care of the alternating part.
Wait, Mr. Ye, number 3 wouldn't have to be the absolute value. It's lower because
No?
technically it would be like lower than higher. Because it's alternating between negative and positive.
No, the a to the n term is not what's alternating. It says a to the n. A to the n is the coefficient.
Oh, yeah.
The alternating thing is the -1 to the power. A to the n is, for example, it's 1 to the n. So it's 1
Oh.
over n.
So it's just like a separate thing tacked on that
Yes.
makes it alternate.
Okay, so let's compare. Well, this one is 1 over n plus 1, right? We don't worry about the -1 part. We're not worried about the negative, like alternating part. Alternating part is it's already part of alternative series test. That is the first part we say that's alternating. We only worry about exactly the sequence part.
Right. So
Okay.
like without the alternating.
Yeah, without the alternating. So now we can compare this. Is this always less than 1 over n? Well,
Yeah.
you can do the math. Let's just do the math. But use intuitive thinking, right? If I plug in 1, it's 1 over 2 is less than 1. If I plug in 2, so it'll be 1 over 3 is less than 1/2. Right? So this one is check. So therefore, of summation of this one, n equal to 1, to infinite of -1 to the n of a to the n is converged. We don't know where they converge to, but we know it's converged due to AST. And I'm not gonna write down the whole thing because you don't have time. You just write down AST is fine. Alternative series test, direct comparison test, DCT, limit comparison test, LCT. Is that okay?
So we don't need to figure out the value of convergence. What?
Yeah.
You're not doing this. I know, but if you do it a few more times, you get one more. No, bro. You listen. You ignore the alternating. Oh, just one over. Like that's the part that's separate. That's the coefficient.
Okay, I get it now.
Is that okay for everybody? Now let's just use some logical proof, right? If let's just say, why is that true, right? And this is a very important understanding. So imagine that this is a 1, and that's 1, right? This length is 1. Okay, let's just do like
Wait, is this a part of the alternate?
that's 1, right? Imagine that this we're gonna do this 1, right? And then we're gonna go back. So this is sum of 1, right? We're gonna go back 1/2. Does that make sense? So this is S2. What'd you say? So that becomes 1/2. Does that make sense? And then we're gonna go to what is the third term? It's gonna be plus 1/3. So 1/3 is roughly the bit here.
Oh,
Is that okay? S3.
but it's negative.
No, 1 is positive.
So this is the 1. This is a 1 minus 1/2. Is that okay?
Yeah.
And this is 1 minus 1/2 plus 1/3.
That's what you're going.
Okay, but it get bigger.
No, you went left and you went left.
Now it's gonna be 1 minus 1/2 plus 1/3 minus 1/4. It's gonna go back 1/4, so it's going to go back 2.
1, 1.
It's like space theorem again.
He's not adding it on. He's not adding it on.
Oh, it's just
Okay.
Okay, so 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5. So that means 1/5 is about, a little bit backwards, a little bit. So that's gonna go back here, like this. So this is S5. Does that make sense? It's gonna become infinite. Like just logical thinking. Like instead of just thinking about what is adding, subtracting, because this is a very important part of thinking because this is gonna give you an arrow. 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5 minus 1/6. So that's gonna go back. Does that make sense? And then it's gonna go like this, like this, like this, like this, like this. So eventually it's gonna be converged. So that's the illustration of what happened.
You know what the actual number is?
We don't know, but we can get very close. We can get very close, and we're gonna talk about it's called alternative series remainder, and that's the things that you have to understand. It actually is pretty good, Kevin. No, it's kind of big.
Yeah. The hair is actually
The hair is accurate.
so freaky.
What did you say?
A light and
Any question about this part?
the last thing.
Well, this is the last thing that so do you understand this part? So long as you can see this, you can say that, oh, okay, that's true. Okay. We're gonna go to the next example. So we already did the alternative harmonic. And you have to prove those three things that's gonna go on. Okay, so I'm gonna show you what happened here. You guys gonna do this one. Is it converge or diverge?
If you don't prove the three things, does that mean it's diverge or it's inconclusive?
If those are you had to make sure that you go in through all the motion. It just told you it's converge, but try to do this one first.
Okay.
No, but like if it doesn't check all three, is it inconclusive or is it divergent?
Try to do this one first. Try to do it first. Go and do all the motion first, and we're gonna talk about it. So the question Marco is posed says, if we fail one part, is that diverge? Yes.
Oh.
Especially the second condition.
Yes. Oh. Doesn't equal zero. It's diverge. Yes, it is.
So then you don't even need to try the third one.
Mm-mm. But you should learn how to do it. So why is the second one that matter? Right? Limit as a n approach thing. Remember that's the divergence test. Because it's not equal to 0, right? If it's equal to 1, then that's failed the n-term divergence test. Not because AST, it's because failed n-term divergence test.
Oh, so you can't say AST.
Mhm.
Where did summations fit into real world applications?
Summation.
Like or this? Well, even the
So for example, that you see a ball that's bouncing. I mean, not like it matter, but a ball is bouncing and it just like a drop of basketball, right? And you want to find out the total distance of the ball that's traveling.
you do this.
You will have to. Well, that's actually. Are we talking about? That's going to be a geometric series. Because each bounce is going to be about 80% of original bounce. Well, probably 70%. What do you think basketball is going to bounce to?
5%.
Maybe 75%? And we can test it. That'd be actually a good thing to test. You drop a ball at a 10 meter, see how much it go back, and how much it go back, and how much it go back, and how much it go back, how much it go back. You can actually find the total distance of that. It's actually a geometric series.
Yeah.
Now, the actual application, I have no clue.
Why don't we just try it out with pizza?
Pizza?
Eat a small amount.
You eat one bite. Oh, you half of that one bite.
Yeah. We buy 2 pizzas for the class. One person gets a whole pizza. The next person gets half a pizza. Next gets a quarter, and then we keep going until all 2 are gone.
We should do it on the time loops. I mean,
On a time lapse.
time lapse, yeah. That'll be actually pretty serious. Okay, so if you do it correctly, right? Is this alternating? Yes. So the first condition is check, alternating. even though this is -1, so first condition, it does check. Second, is the limit n approach infinity of 2n over 4n minus 1. Well, that's equal to 1/2. Since it's not equal to 0, this is going to be diverge. Now, the third condition doesn't matter, but learn how to prove the third condition. So we can take a derivative of this. So f of x is equal to 2x over 4x minus 1. If I take a derivative, I'm going to get 2 times 4x minus 1 minus 4 times 2x over 4x minus 1 to the square. So the top part is going to be ax minus ax. That's going to be -1 over 4x minus 1 squared. Or minus 2, sorry. Okay. So is this always positive or always negative? Always negative. So always negative means decreasing, which is, what's the third condition? That is the third condition. A to the n plus 1 is less than a to the n. It's always decreasing when n is greater than 1. Check. So this one's check, this one's no. So this is diverge.
So on the test, do you want us to show all three, or if it's wrong, we stop at that one?
I will probably stop that one if you don't have time, because you just want to move on to get the answer right. Okay, let's try this one. Is this series converge or diverge? Well, so usually if you have this, the first thing you gotta think about is AST. The first thing you gotta think about is AST. How much time I have?
8 minutes.
Cool. So tomorrow we're going to talk about, is it possible to finding a sum or not, right? So first thing, how do I know it's AST? Well, the AST is right here. It's alternating. Your flow chart is going to think about it's alternating. The first thing you had to do is AST. Does that make sense? So your brain has to go through an n-term divergence test, comparisons test. You got to see the flow chart. Now you see they alternating. Alternative series test will be easiest one to do. First, are they alternating? So check because you have alternating. Second, limit as n approach infinity of m plus 1 over m minus 1. What's the best way to do this?
Just 1 over n minus 1.
I tried derivative, it's annoying.
There's two ways to get to the answer you want. One is the most basic way. I always think about the straw, the basics way. No,
Can't you just compare?
no. What's the most basic way when we're finding horizontal asymptotes?
Oh,
Highest degree of what? Denominator. Good. What is highest degree of denominator? Well, it's n to the 1, right? So I'm going to divide it by n. Divided by n, right? Now, but inside the square root, what am I dividing to? N squared and n squared, right? So this is the easiest way. Why do you think it's too complicated? So never go to more complicated situation if you don't have to. So this one is going to give you a 0. 0. Bottom is going to be 0 plus 0 square root of 1 minus 0. So is that going to be what? 0. Can you do L'Hopital rule? Yeah, but it's a lot more work. Because technically it's infinity over infinity. It's indeterminate. Can I do L'Hopital rule? And if n approach infinity is still equal to 0. So two-way. We had two-way. I'll show you both way. But I love the easiest way. Highest degree of denominator. That's the first way I would think it of. Because what if I forgot how to do derivative? Well, hopefully you didn't forget how to take derivative. How much time I have? What? Cool. What's the next thing we gotta prove? Are they decreasing? What's the best way to prove are they decreasing? Let's take a derivative. What is derivative of this one? It's low. What's derivative of square root of x plus 1? So 1/2 x plus 1 to the negative 1/2, right? So can I just say write a 2 square root of x plus 1? Is that okay? Is that okay for everybody? Minus square root of x plus 1. Because low D high minus high D low over low low. Can I factor out the x plus 1 to the 1/2? What? You can combine fraction, you can do anything. So what if I factor out let's factor out this one. Or you can combine fraction. Let's combine fraction. That's maybe easier. Minus 2 x plus 1 over 2 root of x plus 1 times 1 over x plus 1 square is less than 0. Because we want to make sure that decreasing that must be negative. So what can I do here? That's simplified down to negative x minus 3, right? Over 2 square root x plus 1, x minus 1 squared. So the bottom part is always positive. 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 But the top part is what? Always negative. So it is less than 0. So it's decreasing. So by AST, the series converge. Negative 1 to the m plus m minus 1, sorry. M minus 1 square root m plus 1 over m minus 1 converge. CONVERGE. Is that okay? Cool.
It's on the backboard, on the wall.
Show you homework.
He didn't say anything.
Yeah.
Tomorrow you do.
He had the PowerPoint on. We went over 2 slides at the end of class. Yeah, I think it looks pretty good. Zero.
Zayden, do you understand this? You understand this?
Yeah, I'm actually. I was baffled. I was like, oh my goodness, I can process it. You know what I'm saying? Yeah, exactly. Something is working.
That spinning wheel phone. Windows. What's up, Anthony?
You sit in that seat? Yeah, my fault, bro. I got it.
Move your shit.
I like it.